Chapter 1 of Book 6 of Physics by Aristotle, translated by Thomas Taylor. This LibriVox recording is in the public domain. Recording by Jeffrey Edwards. Chapter 1. If, then, there is that which is continued, that which touches, and that which is successive, as was before defined, viz., that those things are continued whose extremes are one, that those touch whose extremes are together, and that those are successive between which there is nothing of the same kind. If this be the case, it is impossible that anything continuous should be composed from indivisibles, as for instance a line from points, since a line is a continued quantity, but a point is indivisible. For neither are the extremities of points one, since of that which is indivisible one thing is not the extreme, and another some other part, nor do the extremes subsist together, for there is no extremity of that which is without parts. For the extremity is different from that of which it is the extremity. Farther still, it is necessary either that the points from which the continued quantity consists should be continued, or touch each other. The same reasoning also applies to all indivisibles. They will not, therefore, be continued for the reason already assigned. But everything touches either the whole, or a part, or a part the whole. Since, however, an indivisible is without parts, it is necessary that the whole should touch the whole. But the whole which touches the whole will not be continued, since the continued has different parts, and is divided into parts that are thus different and separated by place. Neither will a point be successive to a point, or the now to the now, so as that a length of time will consist from these. For things are successive between which there is nothing of the same kind, but between points there is always a line, and between nows time. Again, if this were the case, continued quantity might be divided into divisibles, since every thing may be divided into those things from which it consists, but nothing continued can be divided into impartibles. Nor can any other genus subsist between points and nows. For if this were possible, it is evident that it would be either divisible or indivisible, and if divisible, it will either be divisible into indivisibles, or into things always divisible. But this is something continued. It is also evident that everything which is continued is divisible into things always divisible. For if into indivisibles the indivisible would be touched by the indivisible, since the extreme of things continued is one, and touches. But there is the same reasoning with respect to magnitude, time, and motion. For either each or no one of these consists from indivisibles, and is divided into indivisibles. And this is evident from the following considerations. For if magnitude were composed from indivisibles, the motion also through the space of this magnitude would be composed from equal indivisible motions. Thus, if the magnitude A, B, C were composed from the indivisibles A, B, C, the motion also D, E, F, with which O is moved through the interval A, B, C, will have each of its parts an indivisible. But if motion being present, it is necessary something should be moved. And if it is necessary that motion should be present if something is moved, if this be the case, to be moved also will consist of indivisibles. Hence O is moved through A when it is moved with the motion D, and through B with the motion E, and in like manner through G with the motion F. If therefore it is necessary that what is moved should be moved from one place to another, and not at the same time be moved and have been moved, whither it was moved when it was moved. Just as if any one walks to Thebes, it is impossible that he should at the same time walk to Thebes and have walked to Thebes. If this be the case, O was moved through A, which is without parts, so far as the motion D was present to it. So that if it should pass after it has passed through, it will be divisible. For when it was passing through, it was neither at rest, nor had passed through, but was between both. But if at the same time it both passes through and had passed through, that which proceeds when it proceeds will be there, and will be moved to whither it is moved. And if anything should be moved through the whole length A, B, C, and the motion with which it is moved is D, E, F, but nothing moves but has been moved through that which is without parts A, if this be admitted, motion will consist not from motions, but from the boundaries of motions, inemata, and something will have been moved which was not in motion, for it will have passed through A by not passing through it. Hence there will be something which has proceeded, though it has never at any time proceeded, for it has proceeded through this, not proceeding through it. If, therefore, it is necessary that everything should either be at rest or be in motion, but it is at rest in each of the parts A, B, C, there will be something which is at the same time continually at rest and continually moved, for it was moved through the whole magnitude A, B, C, and was at rest in every part of it, and therefore in the whole. And if the indivisible parts of D, E, F are motions, it is possible that when motion is present, a thing may not be moved, but be at rest. But if they are not motions, it will come to pass that motion is not composed from motions. In like manner, it is necessary that as length, so time should be indivisible, and be composed from nows, which are indivisible. For if all motion is divisible, but that which is equally swift passes through a less space in a less time, time also will be divisible. And if the time is divisible in which anything is borne along through A also will be divisible. But since every magnitude is divisible into magnitudes, for it has been shown that it is impossible for anything continued to be composed from indivisibles, and every magnitude is continued, it is necessary that what is swifter should pass through a greater space in an equal time, an equal space in a less time, and a greater in a less time, just as some define that which is swifter. For let A be swifter than B. Since, therefore, that which is first changed is more swift, hence in the time in which A is changed from C to D, as for instance in the time F, G, in this time B will not have yet arrived at D, but will fall short of it, so that what is swifter will pass through more space in an equal time. In a less time also it will pass through more space than that which is slower. For in the time in which A arrives at D, B will arrive at E, since it is slower. Hence, because A arrived at D in the whole time F, G, it will arrive at H in a less time than this, and it will arrive at it in the time F, G. The space, therefore, CH, which A will pass through, is greater than CE, but the time Fk is less than the whole time Fg, so that it passes through a greater space in a less time. Hence also it is evident that what is swifter passes through an equal space in a less time, for since it passes through a greater length in a less time than that which is slower, but when considered itself by itself, it passes through a greater length in a less time, as for instance the length LM, which is greater than the length LX. Hence the time PR, in which it passes through the length LM, is greater than the time PS, in which it passes through the length LX. So that if the time PR is less than the time PT, in which the slower movable quantity passes through the length LX, the time also PS is less than the time PT, for it is less than PR. But that which is less than the less is itself less, so that in a less time it will have moved through an equal space. Farther still, if it is necessary that everything in motion should be moved either in an equal, or in a less, or in a greater time, and that which is moved in a greater time is slower, in an equal time equally swift, and if that which is swifter is neither equally swift nor slower, if this be the case, that which is swifter is neither moved in an equal nor in a greater time. It remains, therefore, that it is moved in a less time. Hence it is necessary that the swifter should pass through an equal magnitude in a less time. But since every motion is in time, and in every time it is possible for something to be moved, but everything which is moved may be moved swifter and slower, hence in every time it is possible for a thing to be moved swifter and slower. But this being the case, it is necessary that time should be continued. And I call that continued which is divisible into parts that are always divisible. For the continued being admitted to be this, it is necessary that time should be continued. For since it has been shown that what is more swift passes through an equal space in a less time, let A be that which moves with a greater velocity, but B that which moves with a less. And let that which moves with a less velocity, or the slower, pass through the magnitude CD in the time FG. It is evident, therefore, that the swifter will pass through the same magnitude in a less time than this, and let this time be FH. Again, because the swifter passes through the whole length CD in the time FH, the slower in the same time will pass through a lesser length. Let this therefore be CK. But since the slower B passes through the length CK in the time FH, the swifter will pass through it in a less time, so that again the time FH will be divided. But this being divided, the magnitude also CK will be divided in the same ratio, and if the magnitude, also the time, and this will always be the case if we assume a progression from the swifter to the slower, and from the slower to the swifter, and make use of that which has been demonstrated, for the swifter divides the time, and the slower the length. If, therefore, conversion is always true, and division is always produced by conversion, it is evident that all time is continued. But at the same time it is also manifest that every magnitude is continued, for time and magnitude are divided according to the same and equal divisions. Again, from what is usually asserted, it is evident that if time is continued, magnitude is likewise, since in the half of a certain time the half of a certain space is passed through, and in short a less space in a less time, For there will be the same divisions of time and magnitude, and if the one is infinite, the other is also. As likewise is the one, so is the other. For instance, if time is infinite in the extremes, length also will be infinite in the extremes. And if time is infinite in division, this also will be the case with length. But if time is infinite in both these, length likewise will be infinite in both. Hence the reasoning of Zeno assumes that which is false, viz., that it is not possible to pass through infinites, or touch infinites one by one, in a finite time. For length and time, and in short everything continued, are said to be infinite in a twofold respect, viz., either according to division, or from the extremes. Things, therefore, that are infinite according to quantity cannot be touched in a finite time, but things according to division may, for time is thus infinite, so that it happens that the infinite may be passed through in an infinite and not in a finite time, and that infinites may touch infinites in infinite and not in finite times. Neither, therefore, can the infinite be passed through in a finite time, nor the finite in an infinite time. But if time is infinite, magnitude also will be infinite, and if magnitude, likewise time. For let there be a finite magnitude, A, B, and an infinite time, C. Let also some finite part of this time be assumed as C, D. In this time, therefore, it will pass through some part of the magnitude, and let it have passed through the part B, E. But this part will either measure the magnitude A, B, or will be deficient, or exceed in measuring it. This, however, is of no consequence, for if it always passes through a magnitude equal to the part B, E, and this measures the whole magnitude, the whole time in which it passes through will be finite, for it will be divided into equal parts, as also the magnitude. Farther still, if it does not pass through the whole magnitude in an infinite time, but is able to pass through some portion of it in a finite time, as for instance the part B, E, and this measures the whole, if this be the case, it will pass through an equal part in an equal time, so that the time will be finite. But that it does not pass through the part B, E, in an infinite time, will be evident if a finite time is assumed from the other part. For if it passes through a part in a less time, it is necessary that this part should be finite, since the other boundary is present. There is the same demonstration if the length is supposed to be infinite, but the time finite. It is evident, therefore, from what has been said, that neither a line, nor a superficies, nor, in short, any continued quantity is indivisible, not only in consequence of what has been now said, but because it will happen that an indivisible will be divided. For since in all time there is the swifter and the slower, but the swifter passes through a greater space in an equal time, it is possible for it to pass through a double or sesquialter length, for this may be the ratio of the celerity. Let that which moves swifter, then, pass through a sesquialter length in the same time, and let the magnitudes be divided. That which moves swifter into AB, BC, CD, three indivisibles, but that which moves slower into two, EF, FG. The time, therefore, will also be divided into three indivisibles, for it passes through an equal space in an equal time. Let the time, then, be divided into KL, LM, MN. But again, since that which moves more slow passes through EF, FG, hence the time will be cut into two parts. An indivisible, therefore, will be divided, and that which is without parts will not pass through in an indivisible, but in a longer time. Hence it is evident that nothing continued is without parts. Chapter 2. But it is necessary that the now, which is so called, not through another, but by itself and primarily, should be indivisible, and likewise that such a now should be inherent in all time. For it is a certain extremity of the past beyond which there is nothing of the future, and again it is a certain extremity of the future beyond which there is nothing of the past. It is also that which we say is the boundary of both. And if it can be shown that the now is a thing of this kind in itself, and the same, it will at the same time be evident that it is indivisible. It is necessary, therefore, that the now should be the same which is the extremity of both times. For if it were different, the one would not be successive to the other, because that which is continued is not composed from impartibles. But if each is separate, there will be time between them, for everything continued is of such a kind that there is something synonymous between the extremes. If time, however, is that which is between, it will be divisible, for it has been shown that all time is divisible, so that the now will be divisible. But if the now is divisible, there will be something of the past in the future, and something of the future in the past, for that according to which it is divided will separate the present and future time. At the same time, however, the now will not be a boundary of itself, but through another. For the division is not of that which subsists by itself, to which we may add that of the now there will be something which will be past, and something which will be future, and not always the same past or future. Neither, therefore, is the now the same, for time is multifariously divisible, so that if these things cannot be inherent in the now, it is necessary that the same now should be in each. But if the same, it is also evident that it is indivisible. For if it were divisible, the same things would happen as have been already mentioned in the former argument. From what has been said, therefore, it is evident that there is something in time indivisible, which we say is the now. But that nothing is moved in the now is manifest from the following considerations. For if anything is so moved, it may be moved in it swifter and slower. Let the now, therefore, be N, and let that which is swifter be moved in it through the length A, B. Hence, that which is slower will be moved in the same through a length less than A, B, as for instance through A, C. But since that which is slower is moved in the whole now through A, C, that which is swifter will be moved in less than this, so that the now will be divided. But it was indivisible. It is not possible, therefore, for a thing to be moved in the now. But neither can a thing be at rest in the now, for we say that a thing is at rest which is naturally adapted to be moved, but is not moved when it is naturally adapted, and where and as it is naturally adapted to be moved. So that since nothing is naturally adapted to be moved in the now, it is evident that it possesses no natural aptitude to be at rest in the now. Again, if there is the same moment in both times, but it is possible to be moved in the whole of the one, and to be at rest in the whole of the other, and if that which is moved in the whole time may be moved in any part of this time in which it is naturally adapted to be moved, and that which is at rest may similarly be at rest, if this be the case, it will happen that the same thing may at the same time be at rest and be moved, for the same thing, that is, the now, is the extremity of both times. Farther still, we say that a thing is at rest which subsists similarly, both itself and its parts, now and formerly. But in the now there is not the prior, so that neither can anything be at rest in the now. It is necessary, therefore, that what is moved should be moved in time, and that what is at rest should be at rest in time. Chapter 3. But it is necessary that everything which is changed should be divisible. For since all mutation is from something to something, and when a thing is in that into which it is changed, it is no longer changed, but when it is in that from which it is changed, both itself and its parts are not yet changed. For that which subsists similarly is neither itself changed, nor its parts. This being the case, it is necessary that one part of that which is changed should be in this, but another part in the other. For neither is it possible that the whole can be in both, nor in neither. But I mean in that into which it is changed, viz., that which is first according to mutation, as, for instance, the dark brown from the white, and not the black. For it is not necessary that what is changed should be in either of the extremes. It is evident, therefore, that everything which is changed will be divisible. Chapter 4. But motion is divisible in a twofold respect. In one way by time, in another according to the motions of the parts of that which is moved. Thus, if the whole A, C is moved, the part also A, B will be moved, and the part B, C. Let therefore D, E be the motion of the part A, B, and E, F the motion of the part B, C. Hence it is necessary that the whole D, F should be the motion of A, C. For it will be moved according to this motion, since each of the parts is moved according to each, and nothing is moved according to the motion of another thing. So that the whole motion is the motion of the whole magnitude. Farther still, if all motion is the motion of something, but the whole motion D, F is neither the motion of either of the parts, for each part is the motion of each part, nor of anything else, for where there is a whole motion of the whole of a thing, the parts of that motion will be the motions of the parts of the thing, but the parts of the motion D, F are the motions of the parts A, B, C, and not of other things, for there is not one motion of many things. If this be the case, the whole motion will be the motion of the magnitude A, C. Besides, if there is another motion of the whole, as for instance H, I, the motion of each of the parts will be taken from it, but these will be equal to the motions D, E, E, F, for there is one motion of one thing, so that if the whole motion H, I is divided into the motions of the parts, the motion H, I will be equal to the motion D, F. But if anything remains, as for instance K, I, this will not be the motion of anything, for it will neither be the motion of the whole, nor of the parts, because there is one motion of one part, nor will it be the motion of anything else, because the motion of any continued quantities is continued. This also will be the case if it should surpass according to division, so that if this is impossible, it is necessary that it should be the same and equal. This, therefore, is the division according to the motions of the parts, and it is necessary that it should be the division of everything which consists of parts. But another division takes place according to time. For since all motion is in time, all time is divisible, and there is less motion in a less time. It is necessary that all motion should be divided according to time. Chapter 5. But since everything which is moved in something, and in a certain time, and since there is a motion of everything which is moved, it is necessary that there should be the same divisions of time and motion, of the being moved, and of that which is moved, and of that in which motion is effected, except that there is not similarly a division of all things in which motion is, but of quantity the division is essential, and of quality according to accident. For let the time in which anything is moved be A, and the motion B. If, therefore, it accomplishes the whole motion in the whole time, it will certainly effect a less motion in half the time, and this again being divided, it will effect a motion less than this, and thus perpetually. In like manner, if motion is divisible, time also is divisible. For if it accomplishes the whole motion in the whole time, it will accomplish half in half the time, and again less than half in less than half the time. After the same manner also, the being moved will be divided. For let the being moved be C. According to the half of the motion, therefore, it will be less than the whole, and again according to the half of the half, and thus perpetually. It is possible also, admitting the being moved to be according to each of the motions, as for instance according to D, C, and C, E, to say that the whole will be moved according to the whole motion. For if something else corresponds to the whole motion, there will be many things of which the being moved may be asserted according to the same motion, just as we have shown that motion is divisible into the motions of the parts. For if the being moved is assumed according to each motion, the whole will be continued. In a similar manner also it may be shown that length is divisible, and in short everything in which there is mutation, except that some things are divided according to accident, because that which is changed is divisible. For one part being divided, all the parts will be divided. And so far as pertains to their being finite or infinite, the thing will similarly take place in all of them. But it especially follows that all may be divided, and this to infinity, from that which is changed. For in that which is changed, the divisible and the infinite are immediately inherent. That the divisible indeed is inherent has been shown before, but that the infinite is also will be manifest in what follows. Chapter 6. Since, however, everything that changes is changed from something into something, it is necessary that what is changed, when it is first changed, should be in that into which it is changed. For that which changes proceeds from that from which it changes, or leaves it, and either to change and to leave are the same, or the latter is consequent to the former, and the having left to the being changed, for each subsists similarly with reference to each. Since, therefore, of mutations one is that which is according to contradiction, when a thing is changed from non-being into being, it leaves non-being. It will be, therefore, in being, for it is necessary that everything should either be or not be. Hence it is evident that in the mutation according to contradiction, that which is changed will be in that into which it is changed. But if it is so in this mutation, it will likewise take place in others. For the thing is similar in one and in others. Again, this will be evident to those who consider the affair more particularly. If it is necessary that what is changed should be somewhere, or in something, for since it leaves that from which it is changed, and it is necessary that it should be somewhere, it will be either in this or in another. If, therefore, that which is changed into B is in another, as for instance in C, again it will change from C into B. For it did not adhere to B, because the mutation is continued, so that what is changed when it is changed changes into that into which it is changed. But this is impossible. Hence it is necessary that what is changed should be in that into which it is changed. It is evident, therefore, that what is made will then be when it is made, and that what is corrupted will not be when it is corrupted. For this has been universally asserted of every mutation, and is especially evident in the mutation according to contradiction. That what is changed, therefore, is, when it is first changed, in that into which it is changed, is evident. End of chapter 6 of book 6. Recording in memory of Mitchell Edwards.